Good morning. We're here at the RISC-V Foundation Pavilion at Embedded World 2019 and the Imperas booth with Larry. So good morning, Larry.
Good morning, Rick. How are you?
I'm very well. Thank you very much. Tell me a little bit about Imperas.
Great. Imperas is a company that does software development tools, software development, debug, and test tools based on software simulation, instruction accurate, virtual platforms. So we build models of the RISC-V processors and allow our customers to build models of their peripherals and their SoCs so that they can run their software, test it, and actually do compliance of the RISC-V cores that they're using.
Interesting. So it kind of takes me down a different path. What do you see as some of the major obstacles for adoption of RISC-V, if you think there are some?
Well, I do think there are some. RISC-V is this interesting new technology. It's an open standard, and so it's different than the other instruction set architectures that are out there. One of the key differences is that there needs to be some sort of checking of the compliance to the RISC-V standard, and making sure that that the cores are compliant with the standard is one of the challenges, so that the ecosystem can develop around that. The flip side of that, though, is that one of the great things about RISC-V is that it's open, and that you can customize the RISC-V cores and add in specific instructions so that the users can optimize their SoCs for specific applications. And so there's this interesting balance there.
So if I'm building an SoC and I've got, like, my own proprietary core or accelerator I want to stitch on the side of a general purpose core that I'm licensing from somebody, or one of the open source cores, can I integrate all that in your environment?
Absolutely. Whether it's just a small RB32 microcontroller for an IoT application, or something much larger for some sort of application processor or an AI or ADAS application, we can handle the RISC-V bit of it and the accelerators and other peripherals that go around it.
And am I booting a real OS on top of this, the whole system?
Well, that's the cool thing about instruction accurate simulation, the tools that we have. You have the actual binaries that you've built using the same tool chain as for your silicon, so you run those same executables, those same binaries on the software simulation platform.
So same target.
Exactly the same stuff.
Awesome. Thank you very much. Good to see you. Enjoy the show.
Thanks, Rick.